cruise in 2003, and very soon after that, I presented not the results of the cruise, but the methods we used on the ship. But here, now you have, I'm going to present some of the results, which are co-authored with Rachel Manson, and it will appear as a paper that has been accepted in the Australian Journal of Earth Science in the first issue next year. So Rachel helped me produce quite a lot of the maps that are on display in this talk. I wish to acknowledge the first inhabitants of Australia, put up more of a geological perspective, because people have been here more than 50,000 years. That's 2,500 generations. And these people have seen climate changing, the megafauna, extinction, and so on. And I feel very privileged to be able to talk about some of the findings that some of these ancestors have witnessed. And why study canyon? It's a map that I lifted from a movie from Geoscience Australia that was produced at the time of our cruise in 2003. And it was quite interesting. There were 3 ministers launching this cruise, and all wanted to have the limelight. And one of the scientific secretary told me, if you discover a canyon, you're going to name it after me, won't you? Well, that was the reason why I did not name it after her yet. So why study canyons? And they tell us a lot about processes that had occurred at the time of breakup of Gondwana and some of the marks that it left. And they also act as conduit of unprocessed material from the shelf down to the rapidly down to the abyssal depths. And it's material that hasn't gone through some diagenesis on its way down. Some people also say we can use canyons to actually deliver a lot of waste down to the deep sea. And but I don't think that in Australia will permit this, but this was mentioned at some stage. They also sites of very high biological productivity, and as a result of that, because you've got internal upwelling, you have a lot of whales and dolphins and fisheries as well. So we should actually call some of these canyons to become marine parks, and it's very important. Of course, as soon as we publish some of these images of canyons, fishermen are likely to go there. So we need to preserve biodiversity. And then the question is, are they linked to ancient river systems, or are there any other processes involved? And I'm going to try to answer some of these questions. So Huang et al., who were working as a team from GA, they identified that there are at least 713 canyons around Australia, and you've got the 2 different types. That's quite extraordinary, something that 30 years ago we did not know. And this is the platform we used, the Marion Dufresne, at the time, 120-meter long ship that can have up to 100 people on the ship. Very different from today. In fact, I was able to take 12 students from ANU on this cruise. And one thing also is the best restaurant at sea. But I want to talk more about it. But you can take 60-meter long cores, and then when you bring them back to the ship, you actually can extrude a core along the ship, something that we don't have in Australia. So there were two cruises following the southern margin of Australia, and it eventually went to Antarctica. And I was given 3.5 days of ship time, 3.5 days non-stop. I didn't sleep very much. My biological clock was affected, but it was too exciting. The cruises were to conduct a cartography of the continental shelf and so on. And but we spent 3.5 days, and we studied you've got Kangaroo Island, and we've studied the Murray Canyons. In fact, it's now called the Murray Canyons Group. And this is another map showing in here the red line showing where the ship had been. But we spent quite a lot of time mapping them. And but in 1947, the formidable Red Sprig, a man with vision, there's a photograph of him in Arkaroola, he published a little paper based on data he got from the Navy. During the war, they were looking for sites where to hide submarines and so on. And he produced in this paper a map of the canyons here. He also identified the red arrow shows what he called a pre-Flandrian coastline, so the last glacial maximum. He had vision. By the way, the same year, he published another paper on the Ediacara fauna. It's 1947. And also, he identified or presumed that the canyons were linked to ancient courses of the River Murray. And he had one also coming from Gulf St. Vincent. So after the 2003 cruise, we went back the Southern Surveyor, and we did a lot with Peter Hill and others, a lot of seismic work, and we identified ancient courses of the Murray. You'll see that there was no more link with Gulf St. Vincent. And you can see also that these ancient meanders are at the edge of the canyons. So you compare Red Sprig's map with ours, not much difference really. And he had very crude equipment. And at the bottom, you've got an isopack map of the sediment. We thought at first that this was a large lake, but indeed it was a very large estuary. So we took quite a lot of CTDs and cores in the area. You can see the well-defined last glacial maximum shoreline, and what is now called the Sprig Canyon. And we did an extensive work on these two cores on the flat areas that I used some seismic data that I obtained from GA before the cruise. And I was able to actually go and look for these cores. By the way, after the cruise, since then, we've published 26 papers in referee journals on this. Now, a bit of observation will show you channels in the canyons. So the postulation is they are still active today. They are underwater movement. And the next slide shows a little animation, which I hope will work. An animation generated by Jock Keane. And you have the Sprig Canyon. And I hope I can convince you that you still have active channels, erosion, and transport of sediment down to the abyssal depth. So I will now call this a starved canyon, where you don't have any proper sedimentation in this canyon. And this differs a lot from other canyons that are buried and that will generate in the tertiary. Okay, so here you can, I hope I can convince you that you have what you call meanders and so on and channels. We're going to go eventually to the Spring Canyon East in a minute, but maybe I'll stop this animation because we've lost a bit of time, and here we are. But I hope I can convince you there's no sediment there. Now, I'd like to, I'd like to come and mention another outstanding geologist. This time, Boutakoff, who was the deputy director of the Geological Survey of Victoria. And he mapped the geology of the geomorphology area of a Portland area. He did his PhD in the French Alps. He went to the Caribbean and eventually came to Australia. And his report was published in 1963, but in fact, he'd done most of the work 10 years before. And some of you will know a little bit about the Northwest Shelf. He was one of the person who foreshadowed oil exploration there. And he corresponded with Red Sprigg, who was doing the map on the other side of the border in South Australia. And before I'm going to go back to his report, you have a false color imagery here. You see the Grampians, the Gurry Wolf, and the courses of the Glenelg River. And you can see it's changing courses. And there's a blow-up of this, and there's a Kanawinka fault or scarp, and you can see that the river went through it, but changed courses. And look at it went this way, and then it went to Nelson. And there's possibility that the Glenelg also reached the sea in this area. So I did a field trip early in the year to look at different aspects of the Glenelg that Boutakoff discussed in his report. I had a little car. He must have done it on horses, on bicycle, I don't know. But the important aspect that I would like to present is that the Glenelg is a very ancient river. And you have to look at, for example, the cliffs that are over 30 meters tall near the river, near the mouth of the river. And elsewhere, just like I like history also, and there's a map that was produced by Sir Thomas Mitchell. And again, he illustrated in his book of Australia Felix the very large cliffs near the edge of the near the coast. You can also see Lake George, by the way. Boutakoff, in his monograph, produced his three-dimensional map. He was very skilled at making three-dimensional maps. And you can see the fault line here. And then he identified or presumed I presume that there were ancient courses of the river, and he called them routes. And then through time, he didn't give an age or anything like that, and we still don't have an age for those. And then in another map in his volume, he actually showed the different routes circled here in blue and red and green. But he also linked these ancient routes to different canyons, which he named the Cable, Nelson, and the Rivoli Canyon. And in the same monograph, he produced this map of the area, but it's only a small area that I took from his large map, showing lineaments, linear patterns, which he recognized through the entire of Australia. And if you look at the map, you can see that some of the canyons are running parallel or following the lineaments. Okay, so if you look at a Google Earth map, and in fact, they obtained quite a lot of the information from the survey that was done in 2003 and also before with the Athalon. So you can see clearly the canyons. There's another map showing the canyons again. I've tilted it, and you can see the border between Victoria and South Australia, and Nelson is very close to there. Canyons were already identified, mapped, but not named. In our paper now, they were named, but they were not gazetted. So we now have submitted the name for a lot of these canyons. You can see the Bonnie Canyon. A lot of people will have heard about upwelling in the area, and there was a lot of interest by these two authors listed there about biodiversity. And Jochen Kampf also looked at the upslope sediment deposition as a result of internal upwelling. So this is the map that was produced by Rachel, and you can see the various canyons in here. And also now I'm actually putting on this map the ancient courses that Boutakoff had come up with. And later on, I will talk about a seismic line that you can see. The black diamonds are 4 exploration wells that were done on the shelf. And they are actually very important for some of the arguments that I will present here. So here are the various canyons. And one of them is named after Leanne Armour, who was the executive officer of ANZIC, who died early this year. I had tried to name other canyons after other people, but I was told they have to be dead. And that was not a practice before, because there's a Vonderbosch Canyon, and the Spring Canyon was named while he was still alive. And then there's one canyon called Bocara, which is the traditional name for Glenelg. So I had to get permission from the local community. It took me a while, but I've got permission. So here you have some of these canyons, and I've listed and shown the bathymetry in some ways, and you will see there's quite a lot of undersea slides at particular depth. Okay, there's some here as well. In our paper, we also provide the detailed contours of these. And so you've got the Bonnie Canyon that was described by the previous authors, but those directions follow the linear patterns that you have on land, but they are at greater depth. Other canyons, which are called Bonnie East, they're running into a different direction. So that's something that I think they're much more ancient, but that needs to be investigated. But they start at about 3,000 meters in water depth. So Rachel was able to estimate the length of some of these canyons, and there are different profiles that are summarized in the slide here. And you can see some of them extend down to 120 kilometers. But I hope you can also see a real change of slope, and that needs to be investigated too. Now, I mentioned these underwater slides. Can you see these white arrows here that identify some of the slides? And I would like to argue that a combination of these slides over time actually are the onstart of a new canyon. Okay, I hope I can convince you. I'll show you another image that was generated by Michael Spinocchio when we were on the Southern Surveyor. You can see the white arrows again, shows you these underwater slides. And the next slide, more of these. But I hope I can convince you that some of these here, a series of slides, are the onstart of a canyon. Again, you can see the canyon on the left. There's no sediment in the canyon. There's quite a lot of erosion. So it's very different from the tertiary canyons. Now, I'm going to switch to another topic, and then I'll come back to these in a minute. There's been a lot of work done on the groundwater flow in southeast of South Australia, and we know it's an extremely wet area, and that's why you've got pine forests and so on. And people years ago had to use 200 liters of water to have a radiocarbon date of the water. Today you need 50 mils. But as you go away from the coast, the water radiocarbon, the percent of bottom carbon is increasing. So these waters take a long time to reach the sea, and the red dots, or the red lines, arrows, that's my making, and I'll assume that the water continues flowing in at sea. There's a fantastic PhD thesis from Melbourne University, Angela Bush. It should have been published. It's available on the web, and she has many maps showing you the flow lines, the groundwater flow lines for different aquifers. Here I took the upper one, and you can see the flows at sea. In her thesis too, she has some CTD profile, temperature, salinity profiles, and you can see the two red arrows identify a change of salinity at depth. And it's very interesting to know that there's a lower salinity at 1,300 meters water depth. That's not a coincidence. And but there are other places where you have a change of salinity at sea. Now, some of you will like caving or diving in caves will have heard of Piccaninny Ponds. And it's very close to the Victorian South Australian border. And Piccaninny Ponds is over 100 meters deep, and it's fresh water. And you are only less than a kilometer from the sea. You would expect seawater to enter this karstic environment, but it's not. The water flow is so strong that it's pushing the marine water from preventing it from going inland. And I went to Piccaninny Ponds and took some photographs. So remember, only half a kilometer from the sea or even less. And this is the drain of that water that goes to sea. Okay, and at the side, there's a photograph showing divers, and sadly, several people drowned because with their flippers, they touched the walls of the sinkhole, and there was a lot of calcium carbonate crystals, and the water became cloudy. But people have done quite a lot of work on Bikini ponds and identified that is about, on average, 12 megaliters to 27 megaliters per day flowing through the ponds. For the Glenelg River, and there's a gauge further inland, some 50 kilometers from the sea, and it's not much greater water flow. So there's a lot of water passing through Bikini ponds, and I'd like to argue that there are other sinkholes at sea. Angela Bush again had a cross-section through the area showing the different formation, but in pale blue, when you have hinge zone, that's a sandy aquifer, the Dillwyn formation, and she postulated this direct leakage of water, continental water at sea. And she had a lot of vision. There was a master's thesis done by Baran Dow at Flinders University, and during COVID, I was unable to obtain a copy of this thesis, but other authors, Morgan and others, identified a confined aquifer at sea, but I could not find any more information. However, a very important paper came out in 2019 by people from Flinders University, and they looked at these 4 offshore wells, but then I'm going to pay attention to the Break Sea Reef. You can see Bikini Pond should be around here. And using, they had a novel application using Archie's law and geophysical data and so on to postulate the salinity in the 4 wells. And look at the diagram on the top left-hand corner. You have the horizontal axis is salinity, and the vertical axis is depth. At about 850 meters water depth, the salinity of the water was brackish, okay? And it's only in the sandy aquifers that they found water. That's 850 meters below the seafloor on the shelf. Bush, again in her thesis, mentioned that there are discharges of fresh water offshore Cape Nelson and Port McDonald, such that fishermen can go and harvest fresh water to replenish their tanks. So it must be a huge amount of water. And then John Sherwood from Deakin University heard the same from other fishermen, but no location given. So again, I'll reproduce the same map showing the position of the canyons where Bikini Ponds is, the seismic line that I'm going to refer to in a minute, and the sites of the 4 wells. So the seismic line that was processed, there's a spelling error there, Rosalie Pollock, who at the University of Adelaide, a superb thesis, and you can see the location of the oil well, Break Sea Reef, and the seismic that continues at sea. She logged also the well, and there's a good stratigraphy, and we know where the Dillwyn formation is, and on the left-hand side is an interpretation of the seismic line that she examined. But this is repeated in the next slide will show you a detailed version. And we were able to identify the depth of the breaksea reef. And you have here in blue the salinities of the water, okay? And interestingly enough, that around 700 to 800 meters, you have this low salinity water. Now this is here, but you can see the profile is tilting towards the ocean. So the depth here are quite different for the same formation. And you remember I showed you some of the undersea slides at 1,300 meters. So that's again the enlargement of the slide for breaksea reef by Wright and others, showing the salinities. But further at sea, it's deeper. So I'd like to argue now that these underwater slides correspond to freshwater seeps. And at sea, I don't have a proof. I mean, I need to go back at sea with some instrument to measure salinity, but it's not a coincidence that they occur at about the same depth where the Dillwind Formation is. I'm going to go to Western Australia in a paper published by Neville Exxon and colleagues about the Bremer Canyon and the Whale Canyon. And in this paper, in the Australian Journal of Earth Science, you can see that Exxon and others already showed evidence of canyon heads sapping soft sediment and aquifers. So people have already thought of this idea. And so I hope that I can convince you by proxy that some of these new underwater slides are actually caused by freshwater or low salinity continental water going at sea. I want to argue that this is happening today, but during the glacial periods 20,000 years ago, Australia was much, much drier. There was less water in the aquifers and so on. So I think these phenomena relate to interglacials. Now, I'd like to argue that these submarine mass failures, these undersea slides, need to be looked at. And there was a well-documented undersea slide offshore Scandinavia, and this is taken from different publication. It's called a Storiger underwater slide that is timed at around 8,000 years ago. This map shows you the extent of the slide and then the deposits around Iceland, Scandinavia, and the British Isles, which are tsunami deposits created by these mega undersea slide. And some people even argue that actually changed the climate in the around the Atlantic Ocean. So hopefully this will work. This is again an image generated by an animation generated by Jock Keane at Sydney University. You can see this underwater slide, and we're gonna turn around it, and there's some features that identify as quite a large amount of mass movement at sea. And the next slide will show you Rachel managed to estimate the volume of the sediment transported there. There's another one on the right-hand side. Above the undersea slide, there's a groove there. I'm not too sure if that is caused by the bathymetric data that's not that clear. But I hope to convince you that although the image is a little bit blurred, that you actually have had quite a large amount of transport. Okay. So some of these slides were examined and assessed by Rachel Nansen and estimated the volume of 18.6 cubic kilometer. For another one, 13 cubic kilometer volume. So I'd like to say that some of these slides may have triggered, have the potential to trigger tsunami. Well, I had fun going to the National Library to look at the Belfast Gazette. And it's quite it's a 4-page newspaper. It's from a microfiche, but there's so much information on that newspaper about new medical products and murders and also a lot of information about ships arriving in warning. But on the 24th of December, 1968, it was reported in this Gazette. And a week later, it was reported in a Sydney newspaper. And there's a transcript that on December 24, between 2 and 4, the Moine River, very close to Port Fairy, rose and fell 4 or 5 times. And on each occasion, the tidal went up to 3 feet. I looked at all the references from other side. There's no indication of this phenomenon ever occurred. So I think it's a local phenomenon and likely to have triggered one of those underwater slides. So I would like to argue here that these maybe these need to be a bit better monitored. The public needs to be better informed that they could be. There's been quite a few earthquakes and earth tremors in the area, and they could trigger some of these underwater slides. So my conclusions are several points. There are several deep sea canyons offshore the south coast of Australia, and some of these are likely to have been linked to ancient courses of the Glenelg, the Boutakoff River. And I got permission from the Goody Geomeering traditional owners. I had to go to their office near Portland to argue with them, and they gave me permission to use. And now it's been submitted for gazetting. And the other canyons named after Leanne Armand, a formidable scientist. And in fact, she was one of my first PhD students. There are prolific groundwater seeps offshore the area. I hope I've been able to convince you that although we don't have proof of measuring of fresh water or low salinity water, but that the underwater sapping is quite important. Now, underwater sapping was mentioned in 1938 in the Atlantic coast by a colleague, an American geographer, and then people ignored it after that. But I'd like to argue that this needs to be looked at more seriously. And these cause slumping of the shell and maybe also the early formation of some of the canyons. And I'd like to argue that the groundwater sapping are occurring today, and it would have been 125,000 years ago when you had Australia was extremely wet Lake Eyre was 5 times the size of what it is today. And the other point is that all these slides offshore the same area are starved of sediment compared to the tertiary canyons described by Marco Wallace and Rosalie Pollock. And then I'm saying that they're potentially tsunamigenic. And I think I think maybe I should go and talk to the geological community in Melbourne, or maybe they are watching this talk while drinking some good Australian wine. And so I think that we need to look at that. And I'll finish with a last sketch of the southern view of the Glenelg River, drawn by Eugene von Gerard, and the size has not managed, not changed. So these are my conclusions. Thank you very much indeed.